Hi everyone, welcome to Krish Chemistry. In this video, I am going to solve the question of organic spectroscopy asked in GATE exam. Okay, so this question regarding the concept of multiplicity and chemical shift. Okay, so let us see the question. Here, the correct statements about the 1H NMR spectra of the compounds. Examiner given two compounds here, right? So one is P, second is Q. So this is MSQ question, multiple selective question. You will have one or more than one answers. First of all, I'm talking about this structure P. Okay, so whenever I'm talking about the structure P, so regarding the structure P, I have two options. So the first option is this, second option is this. First option, P shows a sharp singlet at 3.7 ppm for HA and HB. Here, P shows AB quartet centered at 3.63 ppm for HA and HB. In both the options, examiner is talking about HA and HB protons. Okay, and if you observe here, these two hydrogens are attaching to sp3 hybridized carbon atom. Now this sp3 hybridized carbon atom attached to one electronegative atom. Whenever I have sp3 hybridized carbon atom containing one electronegative atom, these two hydrogens chemical shift will lie in between 2 to 5 ppm. 2 to 5 ppm. Now if you observe the options here, in first option given 3.7, in third option given 3.63. That means both the options lies in between these 2 to 5 ppm. So I can't do anything with this data. Okay, so I'm eliminating this data here. Now if you see here, in the first option given singlet, this is the multiplicity. In third option given quartet, multiplicity. So if I can find out the multiplicity, then I can get the answer. Okay, then in order to get this multiplicity, I will go with replacement method. Then what is this replacement method? You have to know. Okay, so for example, I'm giving one example here. See, I'm taking carbon here. Here this is HA, this is HB. Okay, and here this is CH3, this is C2H5. Okay, now I'm replacing HA and HB with any other group. Let us take D. HA is replacing with D and HB is also replacing with D. Okay, so whenever I replace this HA and HB with D, I will get two resultant molecules. So one is HA with D, here HB, CH3, C2H5. This is first resultant molecule. Second resultant molecule, C, HA, D, CH3, C2H5. Okay, so I have two resultant molecules. Now I'm taking the mirror here. So whenever I take the mirror, if, okay, for suppose these two structures are enantiomers, then these two hydrogens will be called as anisotropic. If these two structures are homomers, then these two hydrogens will be homotopic. If these two structures are diastereomers, then these two hydrogens will be diastereotopic. Here you have to remember these 3 points. Points to be noted that if these two structures are superimposable mirror images, I hope you guys know about superimposable and non-superimposable mirror images. If these two structures are superimposable mirror images, then these will be called as homomers. Whenever these two structures are homomers, then obviously these two hydrogens will be homotopic, right? Whenever these two hydrogens are homotopic, then these two hydrogens will give same signal, that is singlet. Again, if these two structures are non-superimposable mirror images, okay, then these two structures will be called as enantiomers. Whenever these two structures are enantiomers, then these two hydrogens will be called as anisotropic. Whenever these two hydrogens are anisotropic, then in that condition also those two hydrogens will give same signal. Okay, now if these two structures are non-mirror images, okay, then these two structures will be called as diastereomers. Whenever these two structures are diastereomers, these two hydrogens will be called as diastereotopic. Whenever these two hydrogens are diastereotopic, then two hydrogens will give different signal. Okay, these 3 points you have to remember. Now, I will apply this same concept to the given question. Okay, see. So in the given question, first of all, I am considering the structure P. Okay, so what is the structure P here? Nitrogen. This structure given, methyl top, carbon, hydrogen at the top, another hydrogen at the bottom, and here pH. This is structure P. Okay, now I am replacing, this is HA, this is HB. Okay, now I am replacing HA with the D and replacing HB is also with the D. HB is also with D. Now, I will get two resultant molecule again. One is this, one is this. Here D, here HB, here pH. Okay, another molecule like this. Okay, and here HA, here D, here pH. Okay, now compare. If you take the mirror image here, okay, if you consider mirror image here, first of all consider these two rings only, not whole molecule. Okay, consider this part first of all. For just a simple explanation, I am just considering these two rings. These two rings are mirror image, both rings are same, right? So these two rings are mirror images of each other. Okay, so whenever these two are mirror images of each other, for simple explanation, I am considering this ring as circle and this ring also as circle. Okay, now I can draw this same thing like this. Now this is circle, this is D, this is H, and this is pH. Okay, now again this nitrogen, same circle because both are same, and here this is H, this is D, and this is pH. Now take the mirror. So whenever you take the mirror, you can easily identify. Now these two are mirror images, but which kind of mirror images? Non-superimposable mirror images. If you take this structure and if you try to insert here, now this D will come to this position. Okay, so these two are non-superimposable mirror images. Whenever these two are non-superimposable mirror images, these are called enantiomers. Whenever these are enantiomers, these two hydrogens are anisotropic. Whenever these two are anisotropic, these two hydrogens will give same signal, that is singlet. Okay, so these two will give singlet. Okay, so that's why for structure P, option A will be the correct answer. Okay, now I will try to replace these same structures. So because I have to take the structure Q now, right? So I'm replacing this methyl group, this methyl group, this methyl group, and yeah, this one. Okay, now see, I'm taking structure Q now. Okay, so in structure Q, this methyl is bottom, and this methyl is bottom, this methyl is bottom. Now compare. If you observe and compare here, okay, if you take the mirror image here, on mirror image, if you compare first of all these two rings are non-mirror images, because if you take the ring like this, if you take this ring, then you will get this kind of ring on mirror image, right? You have to get like this. Okay, so that these two rings are non-mirror images. Whenever these two rings are non-mirror images, that means these two are diastereomers. These two are diastereomers. So whenever these two structures are diastereomers, that means these two hydrogens now diastereotopic. Okay, so whenever these two structures are diastereotopic, okay, they will give different signal. That means this HA will give one signal and HB will give one signal, right? HA, according to n+1 rule, n means number of nuclei, HA because of HB 1+1 2 doublet. Okay, in the same manner HB will also give doublet, so it will give doublet and this will also give doublet. Okay, so totally I can write, according to the options, these two doublets I can write as quartet like this. Okay, so I can write quartet. So according to the given options, option D is the correct option for this structure Q. You can check here. Okay, here for structure P, this will be the correct option, and for structure Q, this will be the correct option. Okay, so this is about this question. I will come up with the new question again. Okay, thank you so much for watching. Take care. Bye bye.